This is the Cycle World podcast. We're back. I'm Mark Hoyer. I'm the editor-in-chief, and I'm with Kevin Cameron. You know him as our technical editor. Hi, Kevin. How are you?
I'm present.
I'm present, too. In the immortal words of Keith Richards, it's great to be here. It's great to be anywhere. This week's podcast is the Harley-Davidson VR1000 Superbike. What a time to witness Harley getting into Superbike racing. And I was there. I was there in 96 at the parking lot race in Pomona. Cones everywhere. Poor Pascal Picot going out for a race start and needing to use the porta-john. And he ran over and bikes are revving and people are running off the grid. And he's like, it's bad enough to try and take a leak when you're wearing leathers because you got to bend over in half and try and get the zipper down and all that. Hard enough. And then to have the pressure of needing to make a start. I was dying. But Chris Carr, man, real bumpy track. And he got a pole, the one and only pole position for the VR1000. And I want to say in the press conference, he seemed as surprised as anyone. So, you did a lot with this bike with Steve Scheibe, and I think you saw a lot of the insides of what was going on. And of course, you're better equipped to ask questions than many of us. So we're looking forward to talking this one over.
Well, the thing that strikes me looking at all of this is that they planned well. Harley bought themselves back from the AMF deal in 1981, and they had to scratch around for money to put this all together. And it was a house of cards for a while.
Worst time to be leveraged. Interest rates were crazy. Everybody threw everything in. They borrowed all this money, the 13 execs, and the worst time to be leveraged.
Yep.
And there they were, but they believed.
We now know they believed.
Yes.
Anyway, it was a tough time, and it was touch and go, but they had a plan. They were determined not to fail. Instead of going back into the business as it had been in 1936, which is the conservative temptation, it always worked before, it'll work now. They decided to adopt just-in-time parts availability. I got the tour at Harley. I walked along this long gallery and I was told all along here were crates of engines. And we weren't always sure what was in the crates. And we weren't always sure that it would fit with what we wanted to put on it. And all this money tied up in inventory. And you know what else happens with inventory? You pay tax on it, which is why dealerships don't have any parts, because they're going to be taxed on those parts. They also adopted statistical dimensional control. They looked at the statistics of what was coming off of a given process, and they could understand the trends in dimensional errors so that they could shrink that down. And as Dr. Deming said so long ago, an increase in quality is an increase in production, because parts that were previously going out the window and into the river, like they did at one outfit in Framingham, Massachusetts, this machinist was famous for quality. Everything he made was perfect because he threw the rejects out the window. They played this game hard, and soon they became the recognized experts in just-in-time statistical process control, and the rest of what was at the time being talked about. This is why the Japanese are so successful. Well, they got the company stabilized. They were set straight by their advertising firm about what they had. What they had was a motorcycle that was American nationalism condensed into solid form. If you rode a Harley-Davidson, you were a red-blooded American. Harley had these plans to compete with Japan with their V4 Nova. Forget that Nova, they were told. That way lies failure. You can't compete with others by copying what they do. You have to have your own edge.
Well, you would want to have your own edge if you have, if yes,
For sure.
You would want to have your own quality of brand. I mean, that's really, it certainly was, kind of nationalism, and I'm a red-blooded American, but it was also, that the cowboy myth, the rugged individualist.
Yes, the high
And
plains drifter.
you could be I mean, it's really for me, it's one of the appeals of motorcycling is that it is a fiercely individual pursuit that you also enjoy with other people.
Yeah.
And I think, you also have that feeling that you get when you ride a motorcycle that's delivering something that you need. And for a lot of people, that is the potato sound, that sound of the 45, clicking it up into whatever your top gear might be, fourth at times, fifth, and then now, oh my gosh, 6 gears.
Yes.
But clicking it up and just like, motoring down the road feels good. Putting out.
So they began to realize that they were succeeding in their plans. And as early as 88, maybe even earlier, there was discussion of Harley used to be big in AMA road racing. AMA road racing has turned into Superbike. And one other thing, V-twins, Harley doesn't make anything else at that time. V-twins are being very successful. Ducati won 3 years in a row in World Superbike with their V-twin. And in AMA racing in 93 and 94, Faraci Ducatis were triumphant. So what could be a better fit? We'll build a V-twin powered Superbike. And to make sure that no one mistakes what it is, we'll paint one side of it orange and the other side of it black.
It was pretty cool. I'd like to. So it's a Superbike, and it needed to be homologated, and they needed to have 50 units somewhere, and they did it for Poland. That was where they sort of could squeak the thing
where they had no emissions requirements,
so they could say, "Here's our bike, and it's for sale somewhere." And they did that. And I was talking to Faraci around that time, and Geraldo Faraci is like, he's one of the greatest human beings I've ever met. Italian accent and a great engineer. And he built, they had varieties of wonderful super bikes, and they made their own pipes, and they just did a lot of really neat stuff. And I'm with Faraci, and I'm like, well, what about this homologation? And he also was very classic with his language, and he said, I'll just clean it up a little bit. And he's like, the freaking AMA. And he was like, he says, I had to he said that he had to air freight like 50 bikes because they were like, we need to see all your bikes. And they had to air freight them over. And it was like before Daytona or something. And he's gone to great lengths to get the bikes there. And he was convinced that there was a circular conveyor belt for Harley, and the bikes were they'd go behind a curtain. That same bike would just come out and you go 1, and then it would go again 2, and then they got to 50, and there you go, hit the track. Yep. He was convinced that was how it was.
It used to be counting the bikes used to be Earl Flanders' job.
Not Flanders.
It was great. So the motorcycle was designed by Harley Engineering. Eric Buell desperately wanted to be involved in it. There was politics going on, the dimensions of which are beyond this discussion. And they aimed for an initial 135 horsepower at 10,000. a goal that was easily achievable, and I think they achieved it. And what they built was a 60-degree V-twin, not the traditional Harley 45 degrees, because with 98 millimeter, nearly 4-inch pistons, the pistons arriving at bottom center, close to one another, would suffer skirt clashing. And even at 60 degrees, they had to use nearly a 2.2 rod ratio. That's the
So
ratio
a long
between.
rod to keep the pistons higher up in the V, essentially.
Yes, absolutely. Thank you. And so the bore and stroke chosen were 98 by 66 millimeters. And if you looked at the Ducati 888, and if you looked at the Britain, which was coming into prominence at this time in the early 90s, they were all around a bore stroke ratio of 1.5. The bore was 1.5 times a stroke. And so the VR was right in the place where it needed to be in terms of bore and stroke. It had in place of Harley's 5-piece and later 3-piece pressed together crankshafts with 1-piece connecting rods and roller bearings, it was an all plain bearing reciprocating train. The rods were side by side on a single crank pin. They had plain bearings. The crankshaft was lubricated from one end. The oil went in and lubricated the crank pin bearing by drillings inside the material.
What are the advantages of a single crank pin?
You will discover the advantages of a single crank pin if you build an engine with staggered crank pins and then try to operate it at race RPM.
Yep.
Harley-Davidson engineers were doing their reading. This engine was not designed in a dark closet, far from the sources of eternal truth in internal combustion engines. These people were doing their studying. But the difficulty with putting the oil into the main bearings and then having it flow radially inward into the crankshaft from the main bearings, that is fighting centrifugal force, and then flow through drillings out to the crank pin, has problems. Honda's RC30 always had black streaks on the rod bearings. They never tightened one, but the black streaks were always there saying, I could hurt you bad if I wanted to. And when they built the RC45, which was RC30 updated, the black streaks didn't go away. They didn't go away until they fed the oil into the ends of the crankshaft.
They did a lot of hocus pocus with the RC45.
Yes, they did. They sure
turned off
did.
the oil pump at high RPM because it was self-pumping, and they gained horsepower, like toward the end of development when they were really trying to wring the daylights out of it.
Well, when they went to end feed, they had to tag the engine. Says, when you run this engine, you will find it has 12 psi oil pressure. That is correct. That's good. Don't try to fix it. And it's common for high-level race engines like Formula One to have 2-speed oil pumps. A high-speed for low crankshaft RPM to make sure that the bearings are up on the step, floating on oil. And then because of the same V-squared problem that we face in damper design, when the engine revved up, it was having to put tremendous force into pumping that much oil. So they slowed the oil pump down, and with a lower ratio. And there's bunches of automobiles now, production cars, that have variable speed oil pumps or 2 speeds.
Well, think of the viscosity. Just think about filling your mouth with water and trying to blow it through a cocktail straw that has a 1/16 of an inch hole in it, and pushing as hard as you can, and you're going to get this little trickle out, and the pressure is
Just
going to be phenomenal.
it's just
Or you take
piddling out.
you take a garden hose and you can go puh, and it's gone. So that's V squared, like the friction of trying to get through that little 16th hole where you're like, "Urgh," it just ain't gonna. You get to a certain point and you can't push any harder. That's
Yep.
what we're talking about with
Yep.
the oil pump.
Now, that takes care of the bottom end. The cylinder heads were designed by the Jack Roush organization. Roush made it big in Detroit by saying, "Oh, you you have 4,000 air conditioners that won't fit in your Cadillac because you made the wrong brackets. We'll make the brackets for you 3 shifts a day, no union trouble." And Jack got to be pretty popular, and he had things that he liked to do, like P-51 Mustangs and Merlin V12s. So anyway, specialist engineering organization. The head they built was 4 valves per cylinder, valves with a 32-degree included angle, meaning a flat chamber that is normally fast burning, very slightly domed pistons. The intake valves were 39 millimeters. The lift was 450, so that's about 30%. Valve lift is 30% of the head diameter, which is in the game. That's Ducati wasn't even there yet. So this is good current practice at the time. And the valve timing was not excessive. One of the temptations when you do your first 4-valve engine is to give it 2-valve timing, and you end up with an engine that has no power, no power. Suddenly there's a bill spike in the torque curve, and that's all she wrote. So you have to keep the air moving at all RPM so that the cylinders will get properly filled. And with a 4-valve, it produces area so much quicker as the valves lift that you don't need as much timing. So it is inherently power band broadening. This is why the Milwaukee 8 valves, 2 cylinders, the latest Goldwing, these are touring engines, but they're giving them 4 valves per cylinder because of this torque broadening effect that you can get with them. So the VR had this same torque broadening effect, but in racing terms. And a single central spark plug, double overhead cam, driven by chain. Now, for some reason, somebody in design said, "Oh, well, V-twins have broad power, so we only need 5 speeds." Well, it turned out later they needed 6 speeds, and the project engineer who had been hired from Roush, Steve Scheibe, thinned the gears, lowered the engaging dogs, crowded everything together, and got 6 speeds in there, and it worked well.
Yeah, that's how they did it with the Quaif. When you put your Quaif into your old Triumph, they just kind of skinnied everything up and stuffed the 6th gear in there. Yeah.
Because back when those gearboxes were originally made, they didn't have 9310L or Astraloy or whatever they make gears out of in modern times. So
they got all these surface treatments now, and they're
that too.
cryo, and they're micro polishing, and
yeah.
A lot
Let's
of
shine it up, and we can charge more for it.
Sure. Well, I think that you discovered that in redoing your RD cranks. And you, at one time, you had to start polishing them because other people were doing that.
I polished a rod once. That was it.
Okay, you didn't polish the cranks or anything?
No, sir.
Yeah. You mentioned I laugh in the notes in our previous discussion about the VR saying they adopted nail head valves, and that Ford discovered that for their 427.
Yep.
And then you go down this long list of people who had used nail. That was in the 60s.
The thing is this: when you look at an intake port in cross section, and the valve is there, in the closed position, Then you lift the valve, and it just seems inherently, instinctively right that the valve should have a curvy tulip form. And the trouble is, it doesn't flow as much air as a disc on a stick. And Douglas discovered this in the 1920s. They didn't say anything about it. It's just that if you look at the parts, you can look at so many parts on the internet. The last groups of parts they made, the last engines, had nailhead intakes.
Amazing.
And Roland Pike, who did all that late term development on the BSA Gold Star 500, he was a nailhead guy. And in 1936, the NACA, they wrote a paper about it. So the VR got nailhead valves. Another proof that they were on the money. They were not designing something vintage. Now, what happened? The chassis was a reasonable length, 55 and something inches. So right in there where it should be. The steering head angle was in the 24, 25 degree area with under 4 inches of trail. Again, numbers that everyone was using at the time.
No, they were really right there in the ballpark. 55.5 inches, 24.5 degrees, and 3.8 inches of trail.
Yeah,
and it works great.
Yeah,
Hit it. Yeah, I mean it's really,
And they of course had a policy, being Harley-Davidson, of using as many American-made things as they could. They had an American-made fork. They had Willwood calipers, 6-piston calipers. They used American wherever they could. And I went to the Grattan Raceway outing when they first put their bike on the track. And it was like when I was a little boy and I was taken to see ballet practice by my aunt. And ballet practice is a bunch of people standing around talking, and somebody puts their toe up pointing to the ceiling and tugs on the underside of their thigh, and they keep on talking, and then they say, well, that's it, let's have lunch. And
you're going to upset the ballet contingent in the audience, buddy.
Well, this was discussion leading up to they're trying to solve problems that they'd had, and where are your marks, So what goes on at the racetrack is the technicians are deeply absorbed in the fuel pump blowing fuses, and out in light rain and cold weather is not the place to diagnose electrics. But here we are at the racetrack. We've got to run this bike.
How many hours? How many dollars an hour is this whole thing?
And have all these people there, sure.
And we're not riding around.
Yep. Well, I suspect that when the VR first went racing, which was in '94, that it was close on horsepower. It may not have had the best power band, but a lot of things were right about it. And what I think happened then is that as they spent quite a lot of money, because each dyno test, each change of cam timing, each adjustment of compression ratio, a lot of these things are penciled in. They wanted 12-1, but they started somewhat lower. And the more valve lift you have, that affects compression, because when you lift the valve higher, you have to cut clearance grooves in the piston crown. And so all these things have to be worked out experimentally, Yes.
Kind of like this one here. You got these
Yeah.
cutouts, and I'm in focus. The piston not so much, but these are the cutouts for the valves.
Good
This
one.
is not a VR1000 piston. This is a Kawasaki 650 piston.
So, all these things require experimentation. It is not possible to go to Google and say, what is the correct design for a 1994 AMA Superbike with 2 cylinders and have it just
but you know what, Kevin? AI will tell you, and there'll be a disclaimer at the bottom that says,
yes,
AI answers may contain mistakes.
may.
It's right there. It says it. They give you all this stuff that could be construed as truth, and then they have a disclaimer. Maybe I should just have my own shirt. I'll put an asterisk on it, and then down here it say may contain errors.
Yes, that's it.
I might not cook your steak perfectly. I'm sorry.
This stuff is costing big money, and there is always a product cheapening officer in every organization. At Kawasaki, they saw some sharp-eyed person saw that they were paying more for connecting rod roller bearings, needle bearings really, than for the production bike. What's going on here? These things that cost 10 times more.
Silver plating, buddy.
Yeah, and little details like rounded ends on the rollers so that the ends of the slots can be rounded rather than right angles, because sudden changes of section and right angles are where cracks they like to nibble.
Well,
and then the cage comes apart. And I've got boxes of cages with bars broken out of them. This is serious stuff.
Well, plain bearing cranks, if you go to this guy in Idaho that I use for crankshafts on real British cars mostly, but what he will do is he'll say like, well, how are you using this motor? And I'm like, well, it's it's run flat out basically, because it's in a Thames van. So it's going to be, he's like, oh, life on a dyno. Okay.
Yeah.
We're going to turn it 40 under. I'm like, no. I'm a street guy. I'm like, no, we got to save the crank. I can't go 40 under right now. I can go 20. He's like, no, we got to go 40, and we'll make a bigger radii. We'll narrow it, and we'll make a bigger radii that way.
Then this
radius for each, and that it contours it. So because if you make that hard turn, just what Kevin said.
There are guidelines for this. There are guidelines for the radius at the edges of the crank pin in a one-piece crankshaft. And so you design your part, and on the drawing, you enter the numbers that have been successful in the past. Except in your case, you get cracking. So then this is exactly the advice that you were given. They go back, they grind under, and they increase the radius so that it is a more gradual turn from the face of the cranksheet to the crank pin itself. Nice rounded corners. Organic shapes succeed where sharp-looking stuff fails. There's a note in some of the development stuff on the VR that said that there was a power gain when they broke the sharp corners on the piston crown where the fly cutter made the valve clearance cutouts. And Nobby Clark, who worked on Halewood's 6-cylinder 250 Honda in 66 and 67, said that they were under orders to break all sharp edges on the tops of the pistons. And if you look there's a wonderful picture on the internet of a person holding a 50cc twin crank in one hand, the crankshaft, little tiny thing.
Yeah.
And the pistons are on the rods, and they've been worked over. The edges of those valve clearance cutouts are radiused.
Well, I've read about those situations where a sharp edge, regardless of what it might be doing to tumble or flow, is a place where heat could concentrate also, because it's so fine.
Yeah.
And so breaking the edge which just means rounding it, like taking the edge of a 2x4 and sanding it,
putting a plane
over it to take the squareness off of it. Yeah.
But there was good knowledge behind the design of this engine. But here is a principle. It is the designer whose name is remembered. And design, which involves conceptualizing something new, gets respect from other engineers. But it is development that makes an engine or a vehicle or whatever you're building functionally successful. Development. And development is terribly expensive. It is so discouraging. And it discouraged the persons whose responsibility was cost control. And another thing that I learned was that the race department under Scheibe was down to 5 people at a point. And that means not enough to do significant development.
Well, imagine Harley at that time in 95. Harley was printing money. They were making every possible motorcycle they could make in the V-twin cruiser market.
Such a success.
And they're really the only problem, the principal problem that everyone was focused on was, how do we make more? It was 100%, how do we increase our manufacturing capacity? That was it. That's what they were thinking about. And so this is a really neat project. But if you're sitting around and you're running a business, and you're going like, yeah, but these aren't super bikes, and look what we're doing. Like, what is this? Like, and it's hard. But I think this is where Honda succeeded. This is where Mr. Honda took racing services, or whatever they used to call it, and made Honda Racing Corporation. It's a separate business that doesn't have to report to the let's make 150s for Thailand and get rich. It gets to do what it's a racing corporation. It's like, no, our success is world championship. That's our success. And it costs a certain amount. Thank you very much. Yeah. And it was separate. And so and there
are guidelines in business for all of this stuff, and you learn them in B school. Walking from class to class, you can contemplate the guideline that says 3 to 5% of any activity should be devoted to R&D. But the product cheapening department is vigorously working to oppose this because that's their responsibility. Money leaking out is like seawater leaking into the hull of a ship.
Yeah.
It can sink the operation.
Well, it's fascinating on running a business like this, where, you're dealing with a passion product, but you have all these unpassionate realities where you just have to do certain things. And then you have
to do them. Yes.
And then you have, engineering has goals, product planning, the people conceiving of the product are like thinking of like, well, wouldn't the customer just love this? And they might just love it, but damn, it's expensive. And so that's where you start arguing. Engineering comes back and says, we can't do that. Do you know how much that will cost? I sat down with the audio guy at Harley-Davidson years ago, and I was like, dude, you know what, with your next big, they called it the boom audio system at the time. And I'm like, dude, next round, you've got to put the subwoofer under the seat, because then the guy's going to feel it riding that bike. Yep. And he's like, oh, but there's no room. It's like, but you could ask, I would ask for that. I would say, you got to put the subwoofer under the seat. And they'd be like, screw you, buddy. You know how much that'll cost? Where are we going to put the whatever? Where's the shock go? You can't do that on a soft tail. Shock's there. Yes. Anyways, sorry.
So in 94, there they are at Daytona. And cell phones were a new thing at the time. I had never seen so many cell phones in one place, and that includes the airport, as there were in the Harley garage, because a couple of people are on the phone to Fuji Heavy Industries because the clutch baskets are breaking. Fuji told them, oh, racing application, spring drive not necessary. In the clutch basket, there's 6 springs.
Yeah, I just witnessed those in the back end of that XS650.
Yep.
replace the clutch basket, and what do you find? Springs back there, and they actually you can renew those springs, and then there are these other damper things you could stick in there as well.
Yep. In some engines it's rubber elements, but usually you see springs. And what that does is when the engine fires, it compresses those springs. And as the firing pressure dies away, the springs push back and it smooths the delivery of torque through the gearbox to the rear wheel.
Hey, everybody, pour yourself a shot. Velocet 500 MSS torque compensator on the crank drive end.
On the crankshaft, yes.
It's splined, and it has 3 big lobes on this cam, and there's a huge spring.
Cam and saddle.
Cam and saddle, and it goes zick, 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 and
the spring is so frightening. I looked at the one on my 500 AJS, and I thought, what if you caught any part of your body in there?
Yeah, it's big stuff.
Terrible. So they're breaking clutch baskets. They're having various other problems. They're all on the phone trying to get all this stuff to Kintetsu Air Service so that it can arrive later that evening. And by this time, they've put a single balancer on the engine.
Well, it was unbalanced. The initial ones had no balancer.
Right.
Yeah.
And of course, you have 2 pistons. They're not moving exactly together, but they're moving nearly together. So the imbalance, the shaking force is like tremendous. And the reason that Harleys in the beginning were not too bad shakers was that the engine was massive and the pistons were not so massive. And as 61 inches became 74, 74 became 80, and on, bigger and bigger pistons shook everything more and more.
Get yourself a 135.
Yep.
We had a 135 through here, and I let one of my, cute road racer guys who rides a lot of multis, and he's like, yeah, I got to try that 135. And he tried the 135, and he's like, I don't know what it is. I think the front wheel's out of balance. The front end's loose, something. And he was really wound up about it. And I was like, huh. To the point that we actually sent it back and had it looked at. And the dude's like, no, everything's fine. And I wrote it, and I'm like, oh, he's so cute. Because the thing was just, it was, they're pretty long stroke, and they're just hurtling stuff back and forth. So you just feel it, folks.
So in the race, the balancer dephased.
Eek.
And the balance weight tried to occupy the same space at the same time with the connecting rod big ends.
Can't have an interference fit there, I don't think.
Just a terrible crunch past start finish. It's a final crunch, and it's not loud. It just goes crunch. And the engine is junk. Everything is junk. Crunch. I used to hear them accelerating from towards what used to be turn 2, the International Horseshoe. Crunch. And then the rider would brake, pull off onto the grass, lean the bike against the fence, and walk back for another bike. Because that one was finished, at least the engine. So these are realities in racing. You're going to break stuff. It's going to be expensive stuff. You need to have plenty of ones just as good as it is, not some second quality junk. You need to have rows of identical engines, all up-to-date spec. Not, well, that's a dyno engine there. It's got 3 hours on it. We could use that. And this is what professional racing teams have, but unless you have an experienced product cheapening department agent, they're going to set traps for you everywhere, and you won't be able to avoid stepping in them. So what this became was a race between the inexperience of the motor company with modern race engine development, which is perfectly understandable. I wouldn't have expected my school principal to do any better. T. Walsh McQuillan. And what happened then was that they took stock. And all this time, Steve Scheibe is is in anguish at he can see the fruit, the low-hanging fruit, and he can almost reach it. And if only certain things were accomplished, he could reach it. But the awful truth is Ducati is pulling away at the rate of 5 horsepower per year. I just went through the figures today. It just, and they didn't seem to have any trouble with it.
I think
851.
it reminds me of a quote of Cal Carruthers, that each season it was last year plus 5% or 3%, whatever,
Yeah.
That's where you start. Well, better get 3%. Let's get going.
Yep. So this is normal, and Ducati is changing bore and stroke, or at least bore, often. 851, 888, 916, 926, 955. And I asked Claudio Domenicali how they managed to retain good, fast combustion in all of these engines. Because I said the Japanese had to stop and fall back a couple of times, Suzuki and Kawasaki at least, when they were following the road to Damascus, which is littered with short strokes. And he said, I can't speak for the Japanese, obviously, but in our own case, we use two things: the intake downdraft angle and intake velocity to boost combustion efficiency. Because the energy that stirs the fuel-air mixture is the energy of the intake process. If you have a great big intake, which the VR had, it's like trying to blow out a candle with your mouth wide open.
That's
The little puff of air doesn't even reach the candle. Or maybe it goes...
The O'Brien quote, was that about how rats could run into the the chamber because it was so big.
He had a look at the early VR, and they wish they hadn't asked him to look, because he said flywheel mass looks on the light side. I never had an engine with the light crankshaft top end right at Daytona. And Muzzy, who worked all the time with inline fours, revving to 14, said the same. And the likely reason for that is that the lighter the crankshaft, the greater the speed variation when the cylinders fire. The crankshaft goes, ugh. Whereas if you have a heavier crankshaft, it goes, ugh. And Honda found that when they developed a valve train to be stable at, say, 14,000 RPM, and on a rig, turning the camshafts with an electric motor, but no crankshaft. Then on the firing engine, they found that valve float began 1,500 RPM sooner because of the variation in crankshaft speed.
Yeah, I think again, we've said this on many podcasts, but it is not an electric motor. There's booms happening, and every time a combustion event happens, it accelerates the crank. And if you have 4 of those, it can smooth that out. If you have a V12, you have a lot of smaller events. But if you have a V-twin, man, you're getting, or a single, every time that thing pops, the crank's going like, yeah, and then slows down, and there's a lot of variation. And then everything has a frequency and a vibration. And so if you have a long camshaft or a cam, like you talked about the cam drive on this thing being outboard of something, and that it was vibrating.
They started out, they had the alternator up against the bearing on the main bearing and the cam drive outboard, and they ended up with some 500-pound shaking force, and they had to move the cam drive. Now that wasn't cheap. It wasn't a matter of just saw this extra metal off and stick something else on here. Make a new crankshaft, make a new cam drive. Scheibe showed me a box that had the sheet metal cam guide shoes, which have molded plastic on it that bears against the chain to keep it from bowstringing. If you allow the chain to bowstring, it builds up in amplitude until the strain, in terms of tension force, is going to crack the side plates. Yes, they're made of steel, but steel is mostly empty space, as we know, tiny little protons and neutrons in the center of the atom, and a kind of like a smell of electrons circulating around the outside of it. Empty space. So R&D development of the engine was not smooth. Most racing engines have some trouble with their cam drives because not only is the crankshaft moving along in a jerky fashion because of the firing impulses, but the camshaft itself is resisting as each lobe comes and tries to heave the valve open. And valve accelerations are thousands of G's. It was a long time ago that I visited those guys in California who were your one-stop shop for pneumatic valves. They said, yeah, 3,000 G's is
West.
It's in the ballpark. And so you've got this thing that is resisting in a series of and the forces are reversing because as the cam lobe passes and the spring begins to push down on the lobe, it's putting power back into the camshaft. So all these gears are going click, 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 click. You can hear that when they're warming up a gear drive motor as that whine. I wish I had a recording of it. Soothing. Anyway, those are violent activities that have to somehow be married to one another, and the cam drive is called upon to do it. Sometimes you'll see, like RC30, late motors had flywheels on the cam. A lot of engines have torsional dampers built into the drive somewhere. The Cosworth DFV had an array of little torsion bars, each with a little tiny lever sticking off of it that would provide the resistance in the space that was available. Because they didn't design it that way to begin with, it had to fit into an existing space. So Keith Duckworth had to sit there looking at this thing until he had an idea. And it cost money to make it. So getting a race engine off the drawing and onto the track costs a lot of money. And then keeping up with Ducati, 5 horsepower more, 5 more, 5 more, that costs a lot of money. And in the end, there's poor old Pascal Picot. He's like an adult. He begins his report with the positive stuff. He says, the chassis is better, the turning is better, but we need more power. Actually, we need about 20 horsepower. This thing is so slow. Well, this was like 99 or somewhere. So, 4 or 5 years at 5 horsepower a year, 20 horsepower is easy. So the final Daytona, and of course, the announcer at Daytona is always trying to make a sob story out of everyone that's having trouble. There used to be a Miami policeman who had more miles on the Daytona track than any living human being.
Oh, yeah.
Was he going to make the program, or was that dirty guy, Matt Mladen, going to qualify so fast that Mr. Policeman couldn't do there
was so much debate about that because Daytona, you used to have like 40, 50 bikes or something, and all those back marker guys, everybody's angry.
And they're riding the turns, some of those people, like they're looking for a contact lens they dropped the year before. And it's, we want them to have a good time, but in the Daytona 200, because as Miguel de Hamel put it, he came into the press room and he was just so angry. You could see that he wanted to draw and fire and kill somebody, because he said, those backmen nearly killed me just now. And he said, I mean, really close. And because when you're racing and you're on the lap record in the middle of a corner, you don't have much extra to allow
Zero
you to
options.
maneuver.
It's a
How?
it's a huge deal. Like at track days, whatever. The slower you go, you could just turn in a corner. You could be at 45 degrees of lean on a modern bike, and you can just like turn it down, tighten your line, like whatever.
Yep. Yep.
And but if you're really booking, you're right there. That's it. You can't just suddenly do something different without crashing.
But of course, the official line is that everyone has qualified, everyone has a right to race, and so it's the officials are acting like, oh well, he'll cool off in a little while, and then we'll whisper in his ear that he has to say it differently. But this is the thing. So practice is going on, then qualifying. The VR is out on the track. It turns in a stunning lap. And we're all looking at each other like, where did that come from? So as soon as that practice is over, the qualifying is over, I go over to see Scheibe and I say, where did that lap come from? That was sensational. And he was in his corporate mode at the moment. Usually not, but at that time he said it was the result of a synergy among the several R&D programs that we ran during the past winter season. And I thought, well, thank you. I'll just jot that down.
Let me write that down. Synergy,
and,
you say.
And then I went to see Dale Rathwell, who had been their chassis consultant for some time. And Dale said, well, he said, it surprised me too, but the fact is that we're in the same position as a college student near the end of term who hasn't kept up with the washing, and he goes to the pile of underwear and he's not those. Well, maybe. So he said we've got an AP carbon clutch in there right now. We haven't used those for years, and we've got heads off of some dyno motor that still look pretty good. They passed, leaked down, and we're using up stuff that we still have, and somehow we hit it. Or the rider had a moment of supreme inspiration. In any case, the background here is that through this whole thing, the engineering department, which designed the motorcycle, except for the heads, which were Roush, the engineering department has been lobbying to let them take over the program because they know how to run a big program. And we know that Harley have produced 4 different new big twins in living memory. And those are big programs that were managed well enough that they didn't break the company. And Scheibe is maneuvering like mad to avoid this takeover. And it's not getting anywhere. And of course, engineering gets in there and they want to break up the activity into engine, driveline, chassis, brakes, etc. And there will be a committee for each one. They'll have meetings. They will set goals, and then they will set metrics. What are metrics? They are ways of measuring how rapidly or slowly you're approaching your goal. It takes a bigger organization than Steve Scheibe and 5 people to run something like that. And then when you get to the end of it, and each department, the engine is now highly superior, the driveline has been greatly improved, the chassis has the right stiffness. How are you going to get all those elements to work together as a motorcycle? This happened to Rolls-Royce when they were developing the RB211 fan engine for the Lockheed 1011. Each department had produced an outstanding. The fan guys produced a wonderful fan that was a step into the future. The low pressure compressor set records. The burner section, the high pressure turbine, all these areas in the engine were highly optimized, but they worked together badly. And there was nobody in the organization who was such a generalist as to be able to say, okay, twist those airfoils this way, you guys pinch this orifice this much. And so the high leadership of the company had to ask a previous employee, Stanley Hooker, to come back out of retirement. And Hooker made his review. He recommended the changes which he thought would allow the various stages to work together. And when a prototype in that style was built at its first test, it was up 6,000 pounds in thrust. So that gives an idea of how important systems integration. It's a wonderful phrase, but it's not so easy to accomplish. How important systems integration is. Because if the motorcycle doesn't work, the rider's going to come in and say, I can't feel the front. So I nearly lost it 4 times this lap. And people are saying, poor old guy, he's past it. Let's get a younger rider. And getting a younger rider has not often worked. Ducati right now, they got an older rider. Marc Marquez, he's older. So having a motorcycle that is a well-integrated system is the goal, not to have wonderful power, wonderful gear changing, wonderful chassis flexibility. It's to have an integrated system that functions. And Harley tried desperately, Scheibe and his people, and then engineering, they tried desperately to achieve that. And they didn't achieve it because, of course, they didn't have the history of 851, 888, 916, 926, 955 to hone all those skills. And the original VR design was a good one at the time. But by the time they had it working well, Ducati was 10 horsepower out of reach. And it just got worse. So what was missing was the experience to tolerate heavy R&D cost. During World War II, Chrysler designed a V16 aircraft engine, liquid cooled, which developed tremendous power. A P-47 was tested with this engine. It went 500 miles an hour. It was tremendous, but they couldn't stop the crankcase from cracking. And there were various other problems that they did not jump on with full force and solve before the war ended. And when Materiel Command saw the problem that they were having, they canceled it. They sent the machine tools to other projects that needed them. And what happened to the great V16? It became the Chrysler Hemi. It was a 2-valve engine. The experience they got with the Hemi chamber became the Chrysler Hemi. So there are a lot of stories like that of outfits that don't have the R&D punch to get the job done in time to be competitive. It's just like war. Time is much more valuable than money. And I talked to a man at Pratt & Whitney who said, this company learned this lesson a long time ago, that when you have a problem, you don't appoint a committee and study it and this and that. You have one meeting in which you identify what might be causing the problem, and you work on all of those possible solutions simultaneously. It's very expensive, but it has a chance of getting the job done before Material Command cancels your contract. So this is something that exists throughout industry. It's not just a racing problem. If you're in the consumer electronics business, you're very familiar with this, because in consumer electronics, everything changes every 6 months. And if you're not there, you're nowhere. So that was the story of the VR. I felt tremendous sympathy for Scheibe and his men. I know that they all worked very hard. I know that there weren't enough of them. That's just how it comes down sometimes. So I was pleased when the motor company produced the PanAmerica, because it is up to date. And they were the first to offer variable ride height as an option.
Yeah, great.
Because what happens when you take your on off-road bike back to the dealer saying, I fell over twice at stoplights, you got to help me. And they lower the bike 3 inches all the way around, takes away a bunch of your wheel travel, but now you don't fall over at the stoplight anymore. Or you can buy this option, and as the bike rolls to a stop at the stoplight, it lowers itself, just like a MotoGP bike.
Yeah, it's real neat. What a great innovation to bring to the market, because it gives you.
And look at all the buses that do it.
Yeah, I mean, you're looking for answer. You're looking. What are you engineering? You want to answer all the questions. You want to do this without compromise. And so, variable ride height gave you that travel and ground clearance that you need when you need it, and also takes it away when you don't. I've been riding the R1300 GS Adventure, and it has adaptive ride height, and it's imperceptible. It's beautiful. You just pull up, and there's a little indicator on the dash, and it says, down arrow with the A in it, and shows the bike, and that means you're in the low position. And then it when you start riding, and you barely feel the change. You feel the change in the way the suspension is working. And then the cool riff that BMW did with it was, when you come and you want to put it on the center stand, you've come to a stop and you're parking, and you want to put it on the center stand, it's in the low mode because you came to a stop. You lower the center stand, it has a sensor, and it says, oh, you want to put it on the stand. So you pause, you push the center stand down until it touches the ground, and then the bike will go, and it raises the rear, and then the front goes, and it's in the highest possible position. And then you just step relatively lightly on the center stand tang, and it goes click. So rather than clean and jerk of 3 or 4 inches,
there you are.
It just raises it right up, and you just tip over center, and you're on the center stand. It's a beautiful thing. It's not as cool as their electro-hydraulic center stand that used to raise itself on the LT. The 1200 LT had this, and I thought, I read about it. I'm like, well, that's a dumb way to spend 50 pounds on your touring bike, because touring bikes don't have to be light, right? They should be as light as you can make them. And then, what's this meaningless feature? What is this? And then I tried it. You pull in 2 up loaded bags, you push that button, and the thing goes up on the center stand. You're like, okay, all right. Yeah. This is pretty cool.
I accept.
Yes, indeed. It was pretty awesome.
So this is it was unfortunate that Harley didn't build an elevator that would take them to the floor they hoped for and allow them to step into AMA Superbike competition on a competitive basis, because there's a chance they would have done it for a long time if they'd been able to fight off the inline fours and the Ducatis in particular. But what this does is it compels your engineers to study the state of the art and to understand what is required. Now, I interviewed for a job at Harley Racing in the spring of 1966. And the gentleman who toured me around had worked his career at a tractor manufacturer. And in retirement, he had this part-time deal going with Harley. And he said to me, now, you have to understand that they're suspicious of college graduates here, so that's going to count against you. He said, what we like to do here is, and remind you, this is 60 years ago. What we like to do is take sharp young guys out of high school drafting classes and set them to work. After about 10 years, they will understand how we like to do things. And then we'll begin giving them design jobs. That's all gone because you couldn't design PanAmerica that way. PanAmerica could only be designed by buying the opposition units, studying them, riding them, taking them apart, measuring. Expensive
benchmarking.
stuff. Yes. And then identifying places where you think, well, why didn't they do this?
Well, yeah, you're critiquing the philosophy behind the motorcycle as well, right? You're making decisions based on what's your brand value. What do you think the motorcycle should accomplish? Ducati comes at an adventure bike in a different way from BMW. They just do, and they're making decisions based on their brand values, how they think it should happen, and you make this chart of qualities, and your circle's over here, and then Harley maybe is over here, and you're making a combination of decisions that you hope brings out the best quality. And I'm an adventure bike, and what should I accomplish? How should I ride? What should I feel like? How should the brakes be? What's the traction control like? How much anti-wheelie? Does it need an automatic? Does it,
When we talked about Softail and Dyno, we took note of the fact that Easy Rider, the movie, came out in 1969, and that by 1971, Harley had product based on the fact that Harleys are cool. In the past, the young and hot-headed bought Sportster, and mom and dad's retired from the Air Force, bought the heavy touring bike. And that was stable adaptation. That was the market. And this 1969 through 1971 thing was a huge step, because it said, if cool is important, let's go for it. Whereas trying to build Nova, trying to compete with the Japanese on their terms, meant ignoring the value of Harley-Davidson to its riders. And as soon as Sportster was out of the midnight drag race scene, Harley riders were saying, yeah, them crotch rockets sure are fast, but if you want something cool, you got to ride what I've got, a Harley.
Yeah, I think Wide Glide, the lore around Wide Glide was guys taking apart police bikes, getting used police bikes and stripping them down, and it had the wide front end on it, and that was where the Wide Glide came from. Yeah, it's
Just as street fighters came from hot-headed young Europeans crashing all the plastic off their bikes and not being able to afford to
well,
replace
yep, it's really pricey. Just crack the egg in the parking lot, man. Let her tip over. Oof. But of course, now all naked, all the naked bikes, some of them even have wings, so it's
them.
not as naked. It's
Yes.
sort of, is it spiritually naked? I guess so, but they're covered up. But yeah, I think I was pretty delighted to see Harley-Davidson get into superbike racing. It was sort of head scratching. I was pretty new in the business, and I was kind of like, well, yeah, but you thought it was cool because obviously it was an international effort anyway. Back even in 95, 94, 93, it was an international effort, but it was cool to have an American company say, we're going to take this route. And that's what's neat, as you pointed out about the PanAmerica, is that I almost think the PanAmerica came from engineering having a chip on its shoulder about people always trashing Big Twins for being, like the detractors who were like, it doesn't make any power. Is that all you can get out of a 105? Is, never mind that it makes 3x the torque at 2000 that some leader bike makes at 9600 or whatever.
Yeah, let's do roll-ons. Let's do roll-ons from comfortable
it's
RPM.
just like, because Harley isn't made up, like engineering is not made up of a bunch of mom and pops who want to ride their touring bikes to Sturgis, or to not even Sturgis, just to the bike night or whatever. It's not that. It's guys like we talked about, Wes Orloff, who's, he's a calibration engineer, but he's also the crew chief for James Rispoli for the Bagger Racing team. And by the way, he's a land speed guy. And by the way, he road races in Arma. And they're just all over the place in that company. All those people they're just broadly based, I would call them Cycle World people in a lot of cases, where you like everything. I mean, I love dirt bikes. I love my dual sport bike. I got that dumb Cressy XS 650. Go check out the Motorcyclist Series Ranwen Park on the YouTube channel of me getting that thing running and then making it a daily rider. Passionate about that stuff, but also testing new bikes and understanding all this stuff. Like, that's what Harley's made of. And I feel like they got tired of being kind of slagged for like building, oh, that's just a big lawnmower, riding lawnmower. At least my lawnmower cuts grass, like all that kind of just like chatter. And never mind the fact that there was buckets of engineering, like Milwaukee 8. I mean, all the things that they did with Milwaukee 8, tuning the vibration, 4 valves, cooling, tremendously broad power, like tons of engineering to make the experience what it is. You're engineering for the experience. But they wanted something, never mind putting everybody else out of business in cruisers. We're going to take a step into the technological arms race, and we're going to build a bike that is technically high performance, and we're going to do it in the adventure class, which is a good class. But anyway, they did it, and it is a great running engine, and it's a good chassis, and they brought the ride height features and all. I mean, it was 100% competitive. In fact, the team over here picked it as the best adventure bike when it came out. So it's there, man. It's truly there.
I wish it had been otherwise for VR.
Well, I mean, it's a what is it? A half commitment. That was the thing.
That's what it was. That's what it was.
They didn't go all in. I mean, I think
started well, good design, good point, jumping off points, and then really R&D didn't stay with the job.
How many dynos are in HRC anyway?
Oh, poor Scheibe. I came back from visiting Aprilia, and he said, "How many dynos they got?" I said, "In all, or you mean the racing department?" He said, "Well, the racing department. Well, I think they have 18, but there's stuff stored in about 6 of them." Oh, 12. Huh. So just, he felt like the nail getting hammered down by everything that happened, made it tougher.
Well, he's still out there. And he's running a team in Motor America, I think.
Yeah, he's a good engineer. He's He's widely read and knows the
Yep.
subject. So, but Ducati jumped into World Supers. Honda won the first two, then Ducati won the next three. So Ducati was going places, it appeared, and it turned out to be the case.
Well, it does align with their business goals more than it did with Harley. I mean, as much as, Harley and racing have been associated since the beginning, right? And I look back at an XRTT and I think, well, that's like one of the coolest motorcycles I've ever seen. It has a vibe, and they're actually, compared to the 750 I was racing in Arma, I think it's steered slower. It was a little heavier. I had a little bit more agility. I did not have motor on it though. It's a 750, and I was riding a pretty well developed BMW 750. This is a Team Obsolete bike. Walt Fulton Jr. was riding it, and that thing ran good, man. It was pulling strong. Anyway, XRTT, XR750. You had all the, they were working with the Air Mach-E stuff, and they were actually doing well with it in the 70s, and then, but it was kind of tapering at that point, and they didn't carry on their commitment with it, and it went away.
And then 1970 came along. They built the Iron XR. They took it to Daytona. They lowered the compression ratio down almost below 6-1. And O'Brien said, in the dyno room, if you turn the lights off, you could see the cylinder heads.
Glowing, as he means.
Yeah. Yes, glowing. And the fuel molecules get in there and into that heat. And they're shaking with the heat, not with the cold, and hydrogen atoms are flying off their fingertips, and they collide with oxygen atoms. Oh, what are we? We are OH minus radicals. How many of us are there? Well, in a few microseconds, there'll be enough of us to detonate. I can't wait. Well, you don't have to. Bluey. And in order to stop those things from detonating, they just lowered the compression ratio down. And for the next year, they made radical changes in that engine, and they were the right changes. But it was still iron. And they moved mountains. And what happens? Calvin Rayborn goes to the match races and blows them away on that 71 modified Iron XR. And then by 1972, the XRTT, the Harley Road Racer, couldn't keep up with a 350 Yamaha. That was the end for road race. And Harley had all kinds of plans to build a big 752 stroke. O'Brien showed me, unrolled these drawings. He showed me drawings for a 2-stroke 400. So what might have been, wonderful stuff, history, because you could see things that nearly happened or that could have happened if only a couple of things had been different.
Doesn't take much.
Supposedly the Russian composer Shostakovich survived Stalin's wrath because the policeman who was supposed to arrest him and send him to the Lubyanka was sick that day. And when he got better, the wrath had settled and the order was rescinded or something like that. And Shostakovich lived on.
Oh, gosh.
The butterfly effect.
Well, I think we can end this one on Shostakovich. We had some we started with molecules. Usually, we got back to molecules and detonation and glowing iron heads of XRTTs. The VR1000. It was a beautiful thing to witness, and it was neat to watch all those guys ride it. Loved the paint scheme. We aspired to even to this day. It'd be kind of cool to try the street version of that with its kind of bubble fared-in headlight and all that. It was pretty cool. A neat effort. You can see them in the Harley-Davidson Museum. They've got them in the They've got fairings hanging on the wall at the back of what I'd call the filing cabinet of motorcycles, where they have all these racks and machines that they can move the bikes
Yeah.
in and out. You can see the Nova that's up there, and kind of they were very good about keeping kind of one of everything over the years, at least one of everything. So they have a great back catalog. Anyway, you can go see the VR1000 at the museum there in Milwaukee.
Yes.
Thanks for listening, folks. We appreciate it. We'll see you down in the comments. There is a link to Prequal Flex for our sponsor, Octane. Go ahead and click that link and check it out, especially if you're shopping. Click it anyway, but if you're shopping, definitely click it, because you can see what you pre-qualify for and potentially go out and buy a motorcycle of your dreams. And we will catch you next time. Thanks for listening.